We are the Sandcasting UGA project, and our group members consist of Lauren Dinko, Allison Hirsch, Wyatt Palmer, Jack Hester, and Mary Beth Start. So an overview of our project is that our group is interested in sandcasting a paperweight that is shaped in the form of UGA with aluminum. So we were able to accomplish this through a process detailed in our next slides and created a successful product, and it showcased our understanding of our casting. So the steps that we took in this project were first to create a CAD design that would make the mold for which we casted the aluminum in. We had to 3D print that CAD design, get the casting equipment, set up the casting equipment, ensure the safety, melt the aluminum can, perform the act of casting, get the final product, polish it, and then reflect on what we had learned.
For CAD design, we first made a preliminary sketch using AutoCAD. This helped us get a better idea of what we wanted as far as shape and relative size of the lettering. For the actual 3D printing, we found it easier to use Fusion 360 for the design, which then had to be converted to an STL. The 3D printer we used was the Lulzbot Taz, and the 3D printing software we used was called Ultimaker Cura. We of course had to apply glue to the printer bed first, which acts as an interface layer to help prevent the material from sticking to the build surface. All in all, the total printing time was 1 hour and 42 minutes.
Our casting equipment included a kiln with a pipe that extruded from it, a crucible within the kiln, casting sand, the 3D prints that we made from the CAD model, coals in the base, lighter fluid, and a hair dryer attached to the pipe that was extruding from the kiln. Of course, aluminum cans and crucible tongs to remove the crucible from the kiln once it was sufficiently heated.
For the casting setup, we first built the cope and drag using wooden screws in the Fab Lab. We then laid the 3D printed UGA side up in the drag and then covered and packed the casting sand tightly. We next flipped the drag over and then put the cope on top, and then using a straw and a wood billet for the vent and screw respectively, and packed the cope tightly like we did with the drag. And then for our fifth step, we removed the cope and gently pulled the print out to reveal the negative mold of the UGA paperweight. We then put the cope back on top of the drag and clamped the two pieces together. We added charcoal and lighter fluid to the furnace and then put the crucible on top of the charcoal. We connected a hair dryer to the kiln to help keep the coals hot, and then we lit the coals and waited for the crucible to heat up so that we could start melting the aluminum. To ensure the safety of all the members of the group, we took into account a bunch of things. So first, for personal protection, all of the group members wore safety glasses, closed-toed shoes. The members with long hair tied their hair back, and none of the members wore jewelry. Anyone that was working with any of the hot items wore gloves, and everyone wore long sleeve cotton shirts and pants. For the environment, we were outside in an open flat surface in the grass. We were not near any flammable items, and we were in a dry area to ensure safety from the electrical items. For inspections, we made sure that everything, including the crucible, the mold, the electric lines, and the cans, were all clean and safe to use before we started the casting.
So here are two videos of the melting aluminum cans into the crucible. After we heated the crucible up, the cans began to melt faster, and we have melted approximately 35 cans. So after melting all the aluminum cans and removing the flake, we prepared to move the crucible full of the liquid aluminum to the mold. We ensured that safety measures were followed, including personal protection equipment and gloves that were used with the tongs. The crucible was readjusted and we were allowed to use proper pouring techniques. After finishing the pour, we waited for the aluminum to solidify and cool. And we waited around 30 minutes to remove the cope and view the results of our cast. And then we continued to wait another 30 minutes to allow the aluminum to cool a little further. Later, we removed the mold and cleaned the excess sand off. And so here you can see the mold still there, and then there is a clean picture with no sand.
We have the pictures of our final project or our final product. We used an angle grinder to cut off the riser stem and the excess from the pouring basin. You can actually see a little bit of the riser stem in the bottom picture. To polish the final project, we used a wire brush, electric and handheld to get into the really tight spaces like in between the A. And in total, this design, cast, and polish took around 5 hours. And some of the lessons that we learned from this project was the importance of removing the flake to get pure aluminum when we pour. And as we learned in class, our 3D mold allowed for uniform thickness, and a laminar pour helped to decrease the porosity, minimize gas bubbles, and decrease cold running. So our product had a few inconsistencies across it, but that was not due to not having uniform thickness. It was due to inconsistencies in the sand. We also learned that just personal protection equipment and a safe environment is very important when you're doing casting. And also to trust our initial process and abilities during the pour. You may not be able to see it in the video, but we kind of thought after we poured it that it went in really fast and that we just thought it didn't work. So just to trust our knowledge and what we're doing. And also, if we were going to use this coat and drag multiple times in the future, I think we would need to coat it in a fire-resistant finish because it caught fire at one point while the aluminum was being poured. It was nothing that couldn't be put out by just blowing on it, but in the future, we would definitely put a fire-resistant finish on it.